Hello and welcome back. In this episode I'm going to show you how you can not only containerize an identity server application, but how you can also containerize an API resource and a client alongside the identity server application itself. So what we've got here on the left hand side in our IDE is our identity server project down here at the bottom. We've then got a console application project which will act as our client. And we've then got an API project, which will act as our API resource. Inside of our API, in the startup class, I have configured authentication and authorization, as you can see here like so. We have the authentication set up to use JWT bearer authentication, and we also have an authorization policy called API scope that is protecting our API endpoints. So that is our API project, and then moving down into our console application project, inside our program class, we go off to Identity Server's discovery document endpoint like so. We then send in a client credentials token request to the token endpoint using our client ID, client secret, and scope of API. And then last but not least, we then use that access token in a new HTTP request to our API. You can see here we have the API URL and also the authentication authority set as environment variables for our application. And then finally, we just log out the response to the console at the end. And then moving down to our identity server project, inside the startup class, you'll notice that we have Identity Server configured to use Entity Framework. It's set up to use a Postgres database, but feel free to use any database that you like for this demonstration. And it's just a simple startup with just Identity Server, no sort of controllers, endpoints, routing, or anything like that set up. It's just using Identity Server. And then in our program class, you can see we are getting the persisted grant DB context and applying database migrations. And we're also doing the same thing for the configuration DB context, as well as adding a console client into a database if the client's table is empty, adding an API scope of just API if the API scope's table is empty, and then adding an API resource of API if the API resources table is empty. And you'll notice we have this data folder here which contains our identity server migrations for both the configuration DB context and the persisted grant DB context. So with our three applications already created like so, you'll notice each one of them contains a Docker file. So if we open up the Identity Server's Docker file, and you can see here we have essentially 4 stages, 1, 2, 3, and 4. So we'll start off taking a look at the second stage here, and this is essentially saying from the Microsoft Container Registry, image.NET SDK version 5. So this is going to pull in version 5 of the .NET SDK. Label this image as build. And then what you're going to want to do within this image is set the working directory, the current directory, to the source folder at root level. Then copy IdentityServer.csproj from our local machine to IdentityServer.csproj in the containers image, in the Docker image. Then run a .NET restore using that csproj file. Then after we've run a .NET restore, copy all of the files from our local directory into the working directory inside the Docker image. And then run .NET build IdentityServer.csproj, so build that project file with the release configuration, outputting the build artifacts to /app/build. So that's the essentially root of the file system /app/build. Now you'll notice that we have this copy IdentityServer.csproj and then run a .NET restore before copying everything from our local file system. And that's because this setup makes use of cached layers within Docker images. So essentially each one of these steps produces a layer of the image, and Docker is clever enough to essentially cache each of those layers. So what it will do, provided that we don't change the CS_proj file, add or remove dependencies, etc., then when we build this image for a second time, Docker will come into this stage and it will say, okay, I've already got a .NET SDK image for version 5, so I'll just use the image I've already got here. Working directory of source, I've already applied that command to another image layer, so I'll just use that from the cache. Copying the CS_proj file, well, the CS_proj file is still identical, so I'll just use the cached image layer that I've got. And then importantly, the .NET restore step would again produce an identical output, and so Docker will just use the cached image layer that it has internally, which means that it will essentially skip all of these steps and move straight down to the copy all step. And that means that we're not running a .NET restore every single time we build the project unless we change the dependencies in that CS_proj file. Given that we've only got sort of 3 projects here, each sort of one with their own individual Docker files, it's a pretty fast build anyway. However, as you can imagine, if you had multiple CS_proj files and lots of dependencies to restore, running that .NET restore command every single time you want to build and spin up the application could start to take a lot of time. So having that .NET restore step separately with just the CS_proj file means that Docker is clever enough to come in here, see that nothing has changed in the CS_proj file, and so it will automatically use the cached .NET restore that it has in its sort of internal image layers, rather than running that .NET restore every single time you do a Docker build, essentially. So that is our build stage of the Docker file, and you'll notice that we label the image as build. Now that's important because moving on to this third stage, you'll see that we say from build as publish. So whereas up here we explicitly specify to go off to the Microsoft Container Registry and pull down version 5 of the .NET SDK, what we're doing here is we're specifying go and look for an image that we've already built that is labeled as build. So this says from build, which looks for an image that's labeled as build, which is this image just here. It then labels this second image as publish, and it then says run .NET publish IdentityServer.csproj with a release configuration outputting the publish artifacts to /app/publish. So it automatically picks up on the current working directory from this image. It automatically picks up on the fact that there is already a CS_proj file within the image and all of the source code is already in the image, because it's saying use essentially this from build, use that build image as the base image to run this publish command within. So as you might be able to guess, this from base as final looks for an image that's labeled as base. And up here at the top we have our base image. We can see we're going to the Microsoft Container Registry, .NET ASP.NET version 5, and we're pulling in this image here, labeling it as base, setting a work directory of just /app, and we're also then exposing port 443 and exposing port 80. Those of course being the HTTP and HTTPS ports that we will use to send requests into and out of the Docker container when the image is running. And so we're saying from base as final, so it uses this image as its sort of base image, sets the work directory to app, and then we can see this copy command is slightly different to the copy command above because we have this -- from equals publish. Now by default, when you're running a copy command, Docker will look on the left-hand side for a folder or file in your local file system on your local machine, and on the right-hand side it will copy that into the location on the right within the Docker image. However, when we say copy -- from equals publish, rather than looking in your local machine, it will look in essentially this image labeled as publish, which is this third image just here, from build as publish, labeled as publish. So it will say, okay, go and find this image that we labeled as publish and copy the /app/publish directory into the current working directory of this base image, which is /app. So it will copy all of the published output from /app/publish, which you'll recall is where we output all of those publish artifacts to in the build step. And then what it's going to do is copy all of those files into the /app folder, the current working directory of this base final image. And then last but not least, it simply uses an entry point of .NET IdentityServer.dll, which is essentially .NET running that IdentityServer DLL. And this is the final step that essentially spins up the application. Once it's finished building the image, it's popped that image into a container, and it's that last entry point there that actually spins up .NET running that application. So that's a brief overview of the Docker file for the Identity Server project. You'll notice the Docker file for the API project is very similar. In fact, it's almost identical apart from the fact we change IdentityServer.csproj to API.csproj, and also the DLL was also updated at the bottom from Identity Server to API. The console application again has a very similar Docker file with console application.csproj instead of IdentityServer.csproj. Exact same thing with the DLL, but you'll notice the stages are exactly the same. The only difference being in our base image we don't expose port 80 or port 443. Because this is just a console application, it's not going to accept incoming requests from port 80 and port 443. It's only going to send outbound requests and it won't receive any inbound requests. So that means that we don't need to expose those ports from within this Docker image. As I say, it's not going to be accepting any inbound network requests because it's just a console application. So that's essentially our API project, our console application project, and our Identity Server project. And in the IDE, if I click on this Show All Files icon, and you'll notice at the bottom here we have a Docker Compose file. And this Docker Compose file is essentially what orchestrates all of those Docker images together into containers. So you can see at the top we have version 3.9. That's the most recent version of Docker Compose at the time of recording. We then have this services list of objects like so. And at the very bottom we have a database volume here at the very bottom. So what I'm going to do is I'm going to go down through each of the services one by one, breaking them down and explaining exactly what each line of this Docker Compose file does. So we start off with a service for our API, and that is going to be a container running our API project over here on the left. You'll see we specify build as our API folder. This tells Docker Compose to navigate into this API folder and look for a file called Dockerfile, which is going to be this Docker file just here. And Docker Compose will then automatically build that Docker file and run it within a container as our API service. You can see we're specifying depends on Identity Server because our API relies on the Identity Server to authorize and authenticate incoming network requests. So we need to make sure the Identity Server is running before spinning up the API. So that's why it depends on the Identity Server application. You'll then notice that we specify a bunch of environment variables. You can see that we're specifying ASP.NET Core environment equals development, and that means that we are running this in our development environment. If you're running this in production, then you can set ASP.NET Core environment to be production, or just leave it out entirely and it will default to production if it's not specified. We then have ASP.NET Core URLs, and that's HTTPS port 443 and HTTP port 80 as the URLs that the application will be running on within the container. We then specify Kestrel certificate's default password and default path. We'll come on to those a little bit later, but that is essentially a path to a PFX certificate that will be used to encrypt the SSL connections over HTTPS, and also then the password that that certificate is encrypted with. And we then have authentication authority equals HTTPS identity server. So this is the authority that the API will use to essentially validate the access tokens that it receives. And we're specifying here HTTPS and then just identity server because identity server is the name of our identity server service. And Docker Compose's internal networking is clever enough to essentially route all requests to just a DNS of identity server to the identity server service that is also running within the Docker Compose orchestration. So we'll see more examples of this a little bit later on, but essentially that means HTTPS identity server routes these requests into the identity server container from the API container. We then specify ports of 5002 and 5003, mapping into port 80 and port 443. On the left-hand side is the port on our local host, on our local machine, and on the right-hand side is the port of the container. So we can say here we're going to localhost port 5002, and those requests will be routed down into port 80 of the Docker container. And the same thing with port 5003 over 443 into HTTPS of the container. We then have a volume mapping. So this is mapping this local path in our local file system into a container path within the Docker container, and it's specifying that to be read-only. That's that RO at the end, read-only, so the container won't overwrite those files. So essentially it's looking for a file in our user folder, and then .ASP.NET HTTPS ASP.NET app.pfx, which is the default ASP.NET HTTPS development certificate. It's mapping that file from our local file system into the container file system at /https/ASP.NET app.pfx. And you'll notice that path matches the default path of the ASP.NET Orchestral certificate. So make sure that this path is pointing to the same directory and file path essentially that we mount the certificate into in the list of volumes down here at the bottom. So that is our API application in the Docker Compose, and we're now going to take a look at the console application. So you can see in much the same way as we have our build API, we are building the console application. So that tells Docker Compose to cd into the console application folder and build the Docker file inside that folder. And that's this Docker file just over here inside console application. You can see it depends on API and identity server because it needs the API running obviously to send a request into the API to retrieve data, and it needs the identity server to be running in order to get an access token before sending that authenticated request into the API. You can then see we have a few environment variables here. We specify the .NET environment equals development. We specify API URL is HTTPS API. You'll notice much like we had with our identity server sort of host name, we can have a host name down here of API, and Docker Compose in its internal networking configuration will automatically pick up on the fact that we have a service called API, and it will therefore route any request to this URL directly into the API container. Obviously we can't specify a local host and then a port number because these containers are all fully isolated from each other. Local host of each container won't have all of the other applications in it because each container is just running the one application and they're all fully isolated. So as I say, each container's local host will only have, in this case, the console application running and nothing else. So it needs to use this essentially service name in the URL for the internal networking configuration to be able to look up the correct service to route the network request to. So that is the API URL, and we also then have the authentication authority. Exactly the same as the API. This is https://IdentityServer. And this again tells the internal networking configuration to route requests to this URL into the identity server container. So that covers our console application. A bit more straightforward because there's no sort of inbound HTTP request or anything like that going on. So it's a slightly smaller configuration compared with our API. Moving on, we have a database. So this database is used to store identity server data. So you'll notice that in our environment variables, we have our Postgres password equals password. Again, we're just running this locally in development, so I'm just using a password of password. Obviously, it goes without saying if you're running this, outside of your local machine, certainly any sort of cloud infrastructure, anything like that, you'd want to use a secure value. But because I'm just running it locally within sort of Docker on my local machine, I'm just going to set it to a password of password for simplicity. And then specifying an image of Postgres 13. You'll notice all of our other services have this build option. However, the DB has an image option instead of a build option. Now that's because the build sort of option here in these other services essentially tells Docker Compose to build the image from scratch. However, in the case of Postgres, Postgres already has pre-built images available on the Docker container registry on Docker Hub. So we can simply say, go off and get me the latest image tagged with 13, so version 13 of Postgres, and just go and pull that image directly. Don't worry about building any images because they've already been built and published in the Docker container registry. So just go to the container registry, find the most recent version 13 image for Postgres, and just pull that down and use that inside the container. We're then specifying ports 5432 of our localhost into port 5432 of the container. That's the default port for a Postgres database server. Again, if you're using a different database server, SQL Server, etc., then feel free to put the correct ports for that particular server in that port mapping. And we then specify this volume here at the bottom. And you'll notice in all the other places we've specified a local path on our local file system. However, here we're just specifying a volume name of DB. And that's because we don't particularly care about having that database data being stored in our, explicitly somewhere that we specify in our local file system. So we just say to Docker, create us an anonymous named volume called DB. And that's what this volumes does here at the bottom, volumes DB. And essentially Docker will then just manage that volume for us internally. So we won't see that on our sort of file system at an explicit path. It will just be managed internally by Docker. Of course, if you wanted to be able to browse those database files from your local machine, then you could specify a path rather than just a volume name here, and that would then mount all of the database's data files onto the specified path in your local file system. And you can see here on the right hand side we're specifying var lib PostgreSQL data, and that's the default data directory for all of the database's data. Again, if you're using a different database server, then you want to update that path accordingly. And what this basically does is it mounts the database's data from the container to this DB volume on our local machine, managed internally by Docker, which means that when we stop and start the containers, we don't then lose the database data. Because otherwise, if we do a Docker Compose down, and then we come back, say, tomorrow and do Docker Compose up, we will have lost all of the file system inside that container because it will be a brand new container with the Postgres image. However, having that volume mounted there like it is like so, that's basically saying go off and mount all of the database's data files into this DB volume. So when we run Docker Compose down, it saves those database files into that DB volume, and when we then come back the next day, for example, and run Docker Compose up, Docker will then mount all of those DB files back into the container. So Postgres will spin up with all of those database files already there, ready to go, without having to recreate all of the databases from scratch each time. So that's, as I say, what that DB volume does there at the bottom. And then last but not least, we have our IdentityServer service. So this is back to specifying the build option with a path of IdentityServer. This means it will look in our IdentityServer folder for a Docker file, which is this Docker file just down here, like so. We specify it depends on DB because this needs the database to store its data in. It's using Entity Framework with a Postgres database. So it's requiring that the DB service is up and running before creating the IdentityServer service. We're then specifying a bunch of environment variables. We're setting the ASP.NET Core environment to development, specifying the URLs to be HTTPS port 443 and HTTP port 80. We're then specifying the default certificate password and the default certificate path as password and /https/ASP.NET-app.pfx. This matches exactly what we've got up in our API service up here like so. And what we've then got is our connection strings default connection. So this is the default connection string for the Postgres database. And you'll notice that the server is simply just DB. Now you might recall this looks a little bit familiar to our URLs that just have a host name of API and IdentityServer. as you can probably guess, server equals DB basically tells Docker Compose to send network requests to this DB server into the service called DB, into the DB container essentially. If you named this service something different, for example database or Postgres, etc., then make sure you update the depends on so it matches, and also the server equals, that should match exactly whatever the service is called. Otherwise, Docker Compose's internal networking configuration won't find a service called DB, and so it won't send the network requests appropriately. Also, we're specifying user ID equals Postgres, that's the default user ID, and also then a password of password, because that is the Postgres password that we used as the environment variable. If you specify a different password here, then obviously make sure you update the password of the connection string. We're then also specifying ports 5000 from our local host into port 80 of the Docker container, and port 5001 to port 443 of the Docker container. And finally, we are mapping that ASP.NET app.pfx certificate from our local file system into the file system of the Docker container at the path https ASP.NET app.pfx, specifying it to be read-only. And once again, that path matches the path that we have in this environment variable, and we exported it with a password of just password. So make sure that matches the password that you use when you export that HTTPS development certificate. So that is an overview of our Docker Compose file, and also of the 3 different Docker files that we have in each of the projects. And so now what we can do is we can essentially spin up all of these Docker containers and see what happens. So with this run configuration selected, Docker Compose, I can simply click on run, like so. As you can see here, it will now take a few moments to build those Docker containers. So it's building those 3 images, API, console application, and identity server, and it's also then pulling down the latest Postgres version 13 image and spinning all 4 of those up into their own individual, fully isolated Docker containers. So we can see there, it's going through now, just creating the networking configuration at the bottom there. And we can see on the left-hand side, we now have this Compose, Docker Compose. If we expand this up, you'll notice our API is running, you'll notice our DB is running, and you'll notice our identity server is running. We can verify that the DB is up and running successfully if we come over here to database tab on the right of our IDE, and if I just refresh that database connection like so, give it a few minutes to introspect the database objects, and you'll notice here we have our identity server database. If we open up the clients table, like so, you'll notice we have our console client. In our API resources, you'll notice we have our API resource, and in our API scopes, you'll notice that we have our API scope. So that's all of the data seeded into the identity server database. So that is all well and good. We can close that database tab back down now. But you might notice this console application here has exited. So if we click onto there, you'll notice that we have this exception. And we can see here the SSL connection could not be established, see inner exception. And we have this exception here, the remote certificate is invalid according to the validation procedure. Remote certificate name mismatch. Now this is an exception that you'll get if you are running multiple services like we are within this Docker Compose file. And that's because the default ASP.NET HTTPS development certificate, which we are using in each of our containers, is only compatible with localhost. However, you'll notice that these URLs here are not localhost URLs. This one here is identity server. This one here is API. We've got another identity server here, like so. Those are not localhost. And as I say, the default ASP.NET Core HTTPS development certificate, which we have mapped as our certificate of choice, is only compatible with localhost URLs. So we can't use that certificate for communication between these Docker services. as I say, they're each running their own sort of container, so they each need to be using a certificate that allows, for example, IdentityServer, API, and not just localhost, because localhost is only really useful for us running the applications on our local machine. As I mentioned earlier, these containers are running in complete isolation of one another, so localhost for each container is just going to be that individual container, none of the other services. Console application, for example, only able to access itself on localhost and not the API, because the API is running in a completely different isolated container elsewhere. Imagine, if you like, those being sort of two completely separate computers running, two completely different applications. Localhost on one computer is going to be different to localhost on the other computer. That's the sort of same concept with the Docker containers running in complete isolation of one another. So what we're going to need to do is, rather than using the default HTTPS development certificate that's provided by the sort of .NET dev certs, we're going to need to generate our own self-signed certificate. So what we're going to want to do is, if we pop into, I've got a Windows terminal here, but you essentially want anything that has access to OpenSSL. So you could be using sort of Git Bash. You might have OpenSSL installed sort of natively. I'm just going to use Windows Terminal, and I have Windows Subsystem for Linux installed, which means if I click on this drop down here, you can see I have this Ubuntu distribution running. So if I simply click on Ubuntu there, I'm automatically directed into an Ubuntu Bash terminal window. Again, as I say, you could be using Git Bash. You might have OpenSSL installed sort of natively. Any sort of environment that has OpenSSL installed, you'll want access to, because we will be using OpenSSL to now generate ourselves a self-signed certificate in order to secure all of these SSL connections inside and between our Docker containers. So if I pop open into the web browser, I've got the OpenSSL documentation handy, and the first thing that we're going to want to do is generate a certificate using the request command. So essentially this is going to generate us a self-signed certificate, and that will give us a public certificate and private key pair. And if we scroll down past the description, there's a few handy examples towards the bottom of the documentation. As we can see here, these examples, we are going to want to generate this self-signed certificate. So you can see here it's OpenSSL and then rec, short for request. We're going to be using the X509 option in order to generate that self-signed certificate. It's going to be a new key and sort of RSA 2048 for the encryption. And you can see then we have key out, key.pem, and then out request.pem. So key out, as you can imagine, is the private key, and then out is the public certificate. So what I'm going to do with that, just there for reference, if I come back into Ubuntu, we can see here I have the OpenSSL request, and I have RSA specified as 4096, just to make it a little bit stronger, 2048 to 4096, the higher the number, essentially, the sort of longer, more sort of secure, encrypted the private key is. And then you'll see I'm specifying a key out of localhost.key. Slightly different to PEM. It's using the key extension rather than the PEM extension, and I'll get on to why those extensions are important in just a few moments' time after we've done these few steps. So specifying the private key to be output to a file called localhost.key. We're then specifying the out parameter, the public certificate, as localhost.crt. Again, that's CRT and not PEM. Specifying that with a CRT extension. We're then providing a subject common name of localhost. So that is the common name of the certificate, just localhost. And we're then adding this extension using the add ext option to add an extension. And we're specifying subject alt name. And this is where we can specify all of the essentially DNS names that we want to secure using this self-signed SSL certificate. So you can see we start off with DNS localhost, which is going to be sort of localhost. So that means that if we want to, we can still use this certificate locally on our local machine in order to secure localhost connections. But then you'll see these two last DNSs, API and Identity Server, those are then used to secure the inter-container communications. That's the sort of network requests between the different containers. So we have the local host part, which is for our local machine. If we are connecting, to any of those Docker containers through our browser via localhost, then we have that DNS of localhost, which means that our browser won't then throw any sort of warning saying, hey, I don't trust that connection, you want to be careful what you're doing. It means that will be secure on our local host. And then we specify DNS of API and DNS of Identity Server, because those are the two service names from within our Docker Compose file. You'll notice the name API there corresponds exactly with what we've called the service here, API, which in turn corresponds exactly with what we use as the host name for the URL, API. Exactly the same thing with Identity Server. You'll notice there that we use the DNS of Identity Server, and that matches exactly what we've called the Identity Server service. Identity Server there, like so, and it's what we use as the host name in the URLs, Identity Server, like so. Again, it's important all of these values match, otherwise, if the certificate was for a DNS name Identity Server 1, for example, then sending a request to just Identity Server here, well, that won't be covered by those DNS names in those subject alt names, and so it once again will fail to validate that certificate for the SSL connection. So if we run this command, that will generate us our private key, and it will ask us to enter a passphrase to encrypt that private key with. I'm simply going to use a passphrase of password, because this is all just locally sort of for development, for simplicity. I'll just use password, but feel free to use any other sort of password value that you like. Just make sure you make a note of it and remember it. And we can see there that it's now generated that certificate for us. If I pop back into our Identity Server solution and pop down to the bottom, you can see that we have localhost.crt and localhost.key. If I open each one of these up, we have our public certificate, like so, and we have our localhost.key, which is our encrypted private key, like so. And you'll notice it's slightly longer than the sort of default, because we specified that RSA of 4096 rather than the default RSA of just 2048, the RSA 2048. So we get a slightly longer, slightly more secure key. Again, this is sort of running on localhost, so you could probably get away with either, to be fair, but we've used 4096 there just to generate that slightly longer, more secure private key, and to show you how you could then do that on your machine. So that's our private key and our public certificate generated like so. However, you'll notice that these are CRT files and key files, but our applications are looking for a PFX file, not a key or a CRT. And so what we need to do now is use both of those two files to generate a PFX file. So back on our OpenSSL documentation, you'll notice that we have this second tab here, and we can use the pkcs12 command to generate ourselves a PFX file. If we scroll down to the list of examples at the bottom of the documentation, you'll notice here that we can parse pkcs12 file, output it to a file. We don't want that one, don't want these, but you can see here we have this example, create a pkcs12 file. And you'll notice it's OpenSSL pkcs12, and we set it to export that PFX certificate. And you can see here it's specifying the in of file.pem and then out of file.p12. Our file extensions are slightly different, so what I'm going to do is jump back into the Ubuntu terminal running via the Windows Terminal app, and here we have our OpenSSL pkcs12 command. So you can see we're specifying it to export that PFX file. We're specifying in to be the public certificate, so it's in localhost.crt, which is our public certificate as an input, and the in key is localhost.key, that's our private key, so it's going to essentially input the public certificate and the private key, and it's then going to output a file called localhost.pfx, and it's that PFX file that we want for our ASP.NET Core Kestrel certificate. And we're then giving it a friendly name of Docker HTTPS Development Certificate. Giving it that friendly name just makes it easier to identify when you're in the certificate manager application. You can scroll down all the friendly names and immediately pick out, this is the Docker HTTPS Development Certificate. Especially useful if you have multiple localhost certificates with the sort of common name of localhost. You might find you've got maybe 3 or 4 certificates all localhost, and if they don't have any sort of friendly name to identify them with, then you're not going to know which one is which easily. So what this will do, as I say, it will take in the public certificate and it will take in the private key, and it will convert both of those to a PFX certificate. So if we run that, it's going to ask us for the passphrase that we use to encrypt localhost.key. So this is the passphrase that we just entered when we were exporting that localhost.key. I just called it password. Again, you may have used something different, so make sure you put in the appropriate password. It should be noted as well at this point, for security reasons, it won't show the captures as you're typing them. So if you're wondering why the cursor is not moving, I have typed password in on the keyboard, but it won't show it on the screen. So just a heads up there if you're wondering why it doesn't look like anything's been typed on the screen in the terminal. And you can see then we enter the export password. So we simply specify, again, I'm going to use password as the password, but feel free to use something different depending on your needs. I'm going to use password there just to verify that a second time. And if we now come back into our IdentityServer solution, you'll notice we now have our localhost.pfx file. So we have our CRT and our key file that we generated first of all, which is our public certificate and our private key. And we then have our PFX certificate, which we can then use to secure the SSL connections within ASP.NET Core. So what we're going to want to do is, you can see in our volumes we have it currently pointing to that ASP.NET HTTPS Development Certificate. We want to change that to point to our localhost.pfx file. So we can simply specify localhost.pfx, which is going to essentially look at the same directory as our Docker Compose file, looking for a file called localhost.pfx. You can see we have the Docker Compose file, and at the same sort of folder level we have the localhost.pfx file. And I'm then going to simply change that to localhost.pfx and update that up there to localhost.pfx. And if I then come further on down, we again do the same thing here with localhost.pfx and localhost.pfx there, and finally updating the path to be localhost.pfx. Again, you'll recall I mentioned during that final step I entered the PFX password of just password, which means that I can keep this default password equals password. If you used a different password to export that localhost PFX file, then make sure you update all of the passwords in this Docker Compose file. Otherwise you will get an error saying that it can't use that PFX file because it won't be able to read it without a valid password. So that is then essentially mounting the localhost.pfx from our local file system into the Docker containers file system at https localhost.pfx. And what we're going to want to do now is use the CRT. Because this is a self-signed certificate, it won't be trusted by default. So when you go to google.com or microsoft.com, etc., those certificates will be issued by a sort of already trusted certification authority. So we wouldn't need to worry about those certificates, but because our application is running with just a self-signed certificate, the Docker containers just running sort of that Linux operating system, they won't know by default to trust those certificates. They won't trust them by default because it won't recognize them. And so we'll still get this same error saying the remote certificate is invalid because it wouldn't be able to trust that certificate. Essentially, it would find it and it would see that it's compatible with the IdentityServer or API URL, but it wouldn't trust that certificate. It's the equivalent basically to going to the browser when you haven't trusted the certificate and getting sort of a big red padlock and a big warning saying doesn't trust that certificate, so your connection is not secure. So what we're going to want to do is we're going to want to trust that public certificate. So what we can do is we can add another volume just beneath our PFX file, and we can mount our localhost.crt, that's our public certificate, and we can mount it into user local share CA certificates localhost.crt, again specifying read only. And what this is going to do is going to mount that certificate into our CA certificates folder. That's our certification authority certificates, because this is essentially our self-signed certification authority, this localhost.crt file. And so what that's going to do is it's going to mount that certificate into the CA certificates folder, and we're going to want to do that for each of our applications. You'll notice, of course, console application doesn't at the moment have any volumes, but we still want to mount that because the console application is going to attempt to make an HTTPS request to the API and the identity server. So whilst we don't need to import and mount that PFX file because it's not encrypting any outbound requests, it still needs to trust that public certificate in order to make the request to the API and identity server. So what we can do is we can specify volumes like so, and we can add that CRT in there, and we can then come down to identity server and also then add that in to all three of those containers as a trusted certificate. And this is all well and good, but there's still one more step to go, and that's because this simply adds the certificate into the CA certificates folder, but we then need to run the update CA certificates command in order for the sort of Linux operating system to import that certificate into its trust store. So what we can do is, just underneath this depends on here for the API, we're going to overwrite the entry point. Now you'll recall earlier on inside the Docker file we specified an entry point of .NET and then our project name .dll, and that entry point is what spins up the application. However, we want to overwrite that entry point because before we run the application we want to make sure that it adds that certificate into the trust store and then runs the application. Otherwise it will run the application and it will make the HTTPS request and it will fail because it won't have trusted the certificate. The certificate is mounted into the file system, but it's not actually imported into the trust store yet. So that's what we want to do by overwriting this entry point with the entry point in the Docker Compose file. And what we can do for that is we can essentially open up a shell terminal. We can specify to run multiple commands, and we can say update CA certificates, and then run .NET. In this case, it's going to be API.dll. So what this is doing, it's saying ignore the entry point in the Docker file, completely discard that, forget about that, and run this entry point instead. And the entry point, as you can see there, is opening up a shell terminal to run multiple commands, and then run update CA certificates and .NET API.dll. So that update CA certificates basically looks inside this user local share CA certificates folder. It looks in this folder for any certificates that it hasn't already trusted, and it will pull in and import those certificates into its trust store. And then once that is done, and only once that is done, it will then essentially run the .NET application. So what we're going to want to do is specify that entry point for each of our applications. So entry point like there, and that is going to be our console application.dll. And then coming down to our identity server, we want to do the same thing again. Entry point, and this is then IdentityServer.dll. So like I say, this is going to first and foremost look inside that CA certificates folder for any certificates that it hasn't already imported, which will be our localhost self-signed certificate. It will import that certificate into the trust store so that it trusts connections to any of those DNS names that we specified earlier, and it will then run the application with the .NET project name.dll. So if we now rerun the Docker Compose orchestration with those added PFX and CRT files and also the overriding of the entry point, we can have a look and see what happens. So coming up into the top right again and running that Docker Compose run configuration, you'll see there it will take a few moments to go through and build all of those Docker containers and spin them up. And if we then expand our Docker Compose, we can see that we have updating certificates in etc. SSL certs, 1 added, 0 removed, done. So we can see that it's added our localhost self-signed certificate. We can see it's then run its hooks to update any other sort of certificates and any other bits and pieces, and it's done. We can then see it's output the token endpoint, which is HTTPS IdentityServer /connect/token. It's output the access token, and we can also see here it's gone off and got data from our API and authenticated that request. And once that's done, we can see it's then stopped the container because it's then reached the end of the program. So essentially what I've shown you in this episode is how we can go from just a single application running in a Docker container using the default ASP.NET Core HTTPS development certificate to spinning up multiple applications, each within their own isolated containers, using a self-signed certificate generated using OpenSSL. And we've then essentially mounted those self-signed certificate files, the PFX and the CRT, into the Docker containers using the volumes option of the Docker Compose. And we've then updated our certificate from the ASP.NET App PFX to our self-signed localhost.pfx. We've then run all of those applications together in their own containers, and we've been able to then send a request from a console application container to an IdentityServer container in order to get an access token. We've then sent a request from the console application to the API container in order to retrieve data, and the API container will have sent a request to the IdentityServer container in order to verify that that token is valid, that bearer token. So as I say, I hope you found this episode useful. Thank you very much for watching, and I'll see you next time.